We're going to try to find the derivative of this function with respect to x. So a couple things to notice about this function right away. Number one, it is composed of two factors, right? It's the product of two functions of x that could stand alone themselves. For that reason, we're going to have to apply the product rule. So I'm going to do some scrap work on the side just to kind of organize what's going on. Some of this is extra once you get good at doing this process, but hopefully by using these colors and kind of working it out slowly, it'll help you understand what's what and why each part is there. So I'm going to let the function g be defined as this first factor, 2 to the tangent of x cubed. Now, I'm going to need both g, that first factor, and its derivative. So after I let g equal that, I'm going to just quickly compute g prime so that I have that at the ready as well. So the derivative of an exponential will have 2 to whatever power times ln2 times the derivative of that power. And the derivative of tangent is secant squared. So it's secant squared of whatever was input to the tangent. Then we have to multiply by the derivative of that input. So times 3x squared. I'm then going to let h of x equal the second factor. And I'm going to rewrite the square root as in 1/2 power. That's going to allow me to compute h prime, or its derivative, a little more clearly. So I'm going to apply the power chain rule. I'll have 1/2 times 4x minus 1 raised to the negative 1/2, right? We're taking 1 away from that power. Then I multiply by the derivative of that inside, right? The derivative of 4x minus 1, which of course is just plain old 4. So when I rewrite this, when I'm actually writing out the derivative of f, I'm going to start out with f prime of x. And that's equal to the derivative of the first factor. And remember, I wrote that in pink. The derivative of the first factor, 2 to the tangent of x cubed times ln2 times secant squared of x cubed times 3x squared. That's the derivative of the first times the second. So I'm going to multiply that by 4x minus 1 to the 1/2 plus the first, and it's exactly how it was. We have that in red. There's our first factor, 2 to the tangent of x cubed times the derivative of the second. That's h prime. Again, I could simplify more. I'm leaving them exactly as is so that it's easy or more clear to see where each of these parts came from. So what I have written out right here, this whole thing, that's f prime of x, piece by piece. The derivative of the first times the second plus the first times the derivative of the second.